sort of the lower left-hand side. Also, all of these faculty lounges are recorded, so if you'd like to share it with your colleagues, you can go back to the faculty lounge page at UEN, and there is a link to past episodes. Okay, so today we have Lisa Cohne here from the Utah Education Network, and she's got some guests from the CIWater project who are going to talk to us about that. But first, I think Lisa is going to introduce and talk a little bit about the project. So Lisa, are you there?
I am. I'm hoping everybody can hear me, and thank you so much, Tim. Here with me today also will be Beth Cable from the University of Wyoming and Tracy Collins from the Utah Museum of Natural History here in Utah to talk about some toolboxes. So we're going to talk about some of the things that CIWater has for teachers. And it's not only Teacher Appreciation Week this week, but and we are also always so appreciative of all our teachers, but it's Water Week. And teachers and water are probably some of the most valuable resources that I can think of. So UEN's really proud to partner on this project called CIWater. And the CI stands for Cyber Infrastructure, the pretty daunting title. But I'm going to show you a little video that gives an introduction and hopefully will make a little more sense. CIWater is part of, CIWater is part of Utah and Wyoming EPSCoR projects. And EPSCoR stands for Experimental Program to Stimulate Competitive Research, funded by the National Science Foundation. And the CIWater project is one of those projects. And this video will highlight the partners in the project from the University of Utah, Utah State University, BYU, the University of Wyoming, and then I'll share with you some of the resources, and UEN is also a partner. Okay, Tim.
We need water to live. We need water for drinking, agriculture, energy, and health. In the Colorado River Basin and the Intermountain West, demands on our water supplies are changing. Today, we know what our water needs are and are beginning to understand our water supply. But we need to know what they both will be like 10, 20, 30 years from now. Without a better understanding of our water resources, it will be difficult to plan for the future to ensure that there will be enough water to meet our changing needs.
CIWater has four main elements to help us get a better idea of how much water we'll have and where it will be so we can plan accordingly. First, we need lots of data on water sources, on how water moves through the landscape, and on how climate change affects the availability of water. Science is producing massive amounts of data. We need computers and computer models to filter the volumes of data and produce the detailed high-resolution forecasts that will be useful for planning. The CIWater project
are beginning to understand our water supply. But we need to know what they both will be like 10, 20, 30 years from now. Without a better understanding of our water resources, it will be difficult to plan for the future to ensure that there will be enough water to meet our changing needs.
CIWater has four main elements to help us get a better idea of how much water we'll have and where it will be so we can plan accordingly. First, we need lots of data on water sources, on how water moves through the landscape, and on how climate change affects the availability of water. Science is producing massive amounts of data. We need computers and computer models to filter the volumes of data and produce the detailed high-resolution forecasts that will be useful for planning. The CIWater project is developing computer models that can process these data and generate forecasts of water availability. CIWater is working on different types of computer models to help us understand how water is likely to behave in certain areas, such as the Colorado River Basin, and also how factors such as climate change and population growth are likely to affect water systems.
To run these CIWater simulations and models, our researchers need computer systems and networks that are faster than ever before. Fortunately, Utah and Wyoming have been working together on building the capacity that we need now and will need in the future to analyze and share these data. This is where the CI in CIWater comes in. It stands for Cyber Infrastructure. To run one of the CIWater models, you need a computer that's hundreds of times more powerful than the typical desktop computer you might have at home or at school. We get that power by combining many of these computers into large clusters, and these clusters are housed in special facilities such as the University of Utah's Downtown Data Center in Salt Lake City and the new NCAR Wyoming Supercomputer Center in Cheyenne. We also need networks to connect these researchers to the data and supercomputer centers so that they can access the data, use the models, and share the results more broadly, not only with the scientific community, but also with the water use community.
Data, models, and infrastructure are useful only if we have people who understand and are able to use them. To help prepare for the future, CIWater is helping scientists, educators, kids, and young adults understand water resource management, water science, computer science, and related subjects. We're developing educational materials, we're hosting science events, we're hosting national speakers, hosting teacher workshops and computer coding camps for teens and young adults. Through these education and outreach activities, CIWater is helping the next generation of water scientists and water resource managers have the necessary tools and knowledge to manage our resources for the future.
So, some of the important people are teachers and students. And I want to show you a little bit more about the resources available to help make some of these amazing changes. I'm going to go to the CIWater.org website. And when you come here, you will land on this homepage, and it can find out more information about cyber infrastructure, data and modeling services, all sorts of things. But because I'm on the education and outreach team, I want to show you all the great things available for teachers here. So the people that we're trying to reach are the K-12 student and teachers, higher education, and water agency professionals, and adult learners. And some of the ways that we're approaching reaching all of these people. Last summer, we had some science and teacher workshops at the University of Utah where teachers from both Wyoming and Utah came together and created a new curriculum. And that curriculum will be released in the fall. So keep your eyes open for that. And I'm pretty sure it's high school curriculum, 9th through 12th curriculum, dealing with both modeling and water. And there's student field research going on, and then the highlight from today are these toolkits that have been developed. So we'll come back to those. And when you come to the education and outreach page, you'll see the video that we just watched and lots of other videos that will help explain what's going on with this project, lots of the research that's happening. There's some information about what's going on with higher education, great virtual poster session. And then pay attention to the events and programs. It's a little late in the year, I know, for this SURAP program, which is the Summer Research Apprentice Program. But come back, I'm hoping teachers will really pay attention to this, both in Utah and Wyoming, for next fall. If you've got high school students who are really interested in hydrology and resource management, environmental science, as well as modeling and water systems. This is a great opportunity that happens at the University of Wyoming every summer. And it's a really nice stipend involved too. It's free room and board, and kids can make money and learn. So I just want to point that out so that teachers teachers can remember to go there next spring and recommend that for your students. Also under events and programs, there are different code camps. And this year I know also we want you to come back to this site because registration will begin for Utah State hosting their code camp for high school students coming soon. So then I just quickly want to show you some interactive resources and tools before I introduce Beth and also Tracy, who's here from the Natural History Museum to talk about the CIWater toolboxes. But we have lots of curriculum divided by grade level and interactive activities about water and research. Also, really fun thing that we've posted here is called Aquapedia. And I love this website. It's Wikipedia for and about water. So if you've got kids doing some research on the Colorado River, I love it. You can just come here, click on Colorado River, and there is so much information. One of the really cool things, if kids are doing research, it's a great resource, the Colorado River timeline. All of the laws, all of the history, right here with lots of wonderful links. So just some powerful tools that are really fun and great opportunities for teachers to share with their students. The other thing, the other people that we're trying to reach is the community. And since it is Water Week, UEN and I'm pretty sure there's some programs in Wyoming as well with the public broadcasting station all about water. This entire week, UEN has devoted their evening broadcasts to educational resources about water. We even changed and made sure that all of the Bill Nye programs each afternoon this week were all about water. So I know it's kind of late in the week, and if you are not able to watch any of these programs, we still have some resources on the website with our water-related programs that you can look and find out when they're going to be on television and maybe if they're in UEN's eMedia. Okay, with that, I'm going to go back here and introduce Beth Cable, who helped develop the CIWater toolboxes. She's going to all of those, some of the great resources. We're going to go into more detail, and she'll also make sure that if you're a Utah teacher, you know how to access those in Utah as well as Wyoming. All right, Beth.
Hi, everyone. Thank you, Lisa. My name's Beth Cable, and I am an Education Outreach and Diversity Coordinator for EPSCoR Wyoming. And these toolboxes that I'm about to tell you about were collaboratively created and built as a cooperative effort through the Natural History Museum of Utah and EPSCoR Wyoming. And these were funded through a National Science Foundation Track 2 grant, which is, like Lisa said, CIWater. So the toolboxes are divided into primarily 4 main sections, and those include properties of water, water in the environment, human use and impact, and what do we do now? And within each of these sections, these key ideas, there's a variety of activities and tools that fit themselves within these sections. And we listed here just a few of many examples of the activities and or themes and topics that are covered under these sections. So the properties of water includes activities that introduce and teach about like the biology and the chemistry of water, such as adhesion and density and evaporation. Water in the environment includes many of the water sampling tools, water quality testing, a lot of the outdoor field projects that you might be able to do with students. And it also includes information and activities on the watersheds and groundwater. And the human use and impact studies our impact on these water systems, as well as many of the risks to water quality. The students can determine their impact on their water system by measuring and recording their water use over a given amount of time, and maybe doing that within their classroom or their school to really understand the impact that they have on their water system and what they might do to conserve a little bit of that water. And then the last section, what do we do now? We didn't want to leave the students and the teachers just sort of in a state of dismay where, boy, this just doesn't really sound all that positive for me in my future. So we created a section of what students can do to help. And this includes art and advocacy projects, maybe creating and planning a community action project or some sort of water conservation program within their school or their community. And so, like I said, each of these 4 sections have a variety of activities and lessons that you can find within each section. And the beginning of the curriculum, so before you would start any part of, and they don't have to be certainly done consecutively or consequentially, you can kind of pick and choose from any of the areas. But there is also a pre and a post brainstorm activity that really bookends anything that you decide to do within the toolbox, just to get a feel for what your students come into, what their prior knowledge is on water and their environment, and then what they get after your section with the toolbox. So sort of a post brainstorm, see what you learned activity. And also within each lesson plan are 9 essential questions that we created as really a very overall theme, sort of questions that we were hoping that students and teachers would be able to answer when using this toolbox. And these are the same for every single lesson. And like I said, there are 9 of them, and I'll just read a few of them so that you can have an idea. Questions such as, where does water come from? What impact does water have on the environment? What impact does the environment have on water? How does human growth and development impact water resources? How does climate change impact water resources? And how does technology influence water research? So each of the lesson plans are hopefully at least answering some or most or all of those questions. So using the CIWater toolbox, the boxes are comprised of 3 transportable toolboxes, 2 with the many tools and books that can be used with the lessons, and then 1 toolbox is simply a groundwater model. And these activities and these boxes are designed for K through 12 teachers and students, and they also have been used with community groups, so very effectively and efficiently with nonprofits and community groups outside of the schools. The boxes include a large lesson binder of curriculum, activity ideas, and field guides. And they also include modeling, as modeling is a large part of the CIWater grant. And the models include the groundwater model tank, which I spoke of, which comprises 1 of the 3 boxes, the Metoric water model tank, which is actually part of that groundwater model, and a Thermohaline Circulation tank, which I'm going to talk about just a little bit later. And then they also include supplemental materials such as books, games, and DVDs. And in addition to the essential questions that I just shared with you, each lesson plan has a section of enduring understanding. So for example, I just grabbed one of the lessons called Bending Water. And under enduring understanding, it describes water is a polarized molecule. This can be demonstrated through simple tests. So it's just a very brief summary of what that activity is about. And then it has the grade level. For example, this one says 2 through 8, the activity length, 30 to 45 minutes, and the process skills. And bending water process skills include observation, data collection, and analysis. So in the introduction of each lesson plan, there is a box that covers all of these items. And these are just two pictures of what the water toolbox looks like if you haven't seen it yet in your state. The picture on the left is, like I said, they are fairly large. They do come on wheels so that you can kind of drag them along like a wagon. And there are 3 of them, one of which is the groundwater model. And one of the more popular, it seems, lessons, activities is the Thermohaline Circulation lesson, one of the models within the boxes. And the thermohaline circulation is driven by density differences within the water. And it uses a thermohaline circulation tank, which you can see here. And you clip this heat source, the light, the funnel, and the fan to the tank. And so you can ask your students, well, do you want the water in the tank, which could be, the Great Salt Lake, or it could be the Platte River here in Wyoming, or, maybe any local water source, so that they can kind of wrap their heads around something a little more local. And do you want this to be warm or cold, salty or fresh? And the students can kind of chime in on what kind of water environment they want to create. And then you go ahead and introduce almost the opposite of what that water tank, what the water in the tank is. So if they decided they wanted their water to be cold, you might introduce warm water. And if it's fresh water, you might introduce warm, salty water. And so adding a little bit of dye, food coloring, to that water and then pouring it through the funnel really allows the students to see how the density differences of this water begins to circulate within the water body. So you can turn on the heat source and observe by writing and drawing and taking notes. You can turn on the wind source and observe by writing and drawing. And just really, the students can ask a lot of questions, and you can repeat this process with many of the different variables, such as ice cubes, salt, and just each time adding water to that is a different color, so you can really begin to see how this water circulates according to the density. And then the second more popular lesson, if you will, that I will talk about is the hydropoly game. And clearly this hydropoly game was modeled after Monopoly. However, the biggest difference is in the game of Monopoly, the player is trying to collect as much money as possible, where in hydropoly, the player is trying to collect as little gallons of water as possible. So these gallons of water are represented by blue glass pebbles, and it's played very similar to Monopoly. So the players, 2 to 8 players make their way around the board, and they can buy property, and buying property by water, by taking and returning water to the water system by these pebbles, and they can draw impact and community action cards. And an example of one card here, community members start walking, biking, and using public transport more, return 5 gallons of water. So through playing the game, even just for a short amount of time, students begin to learn about and participate in a lot of different positive and negative consequences of things that they may do in their everyday life on the water system, on the water cycle. And so the play stops, or the game is over, when all of the water from this water cycle is gone. And like I said, the winner is determined by that player who has the fewest gallons of water. And yes, you can check these boxes out. I see a question in the chat there that can we check these out? And yes, they can be checked out. And I'm just going to tell you quickly how, and if Tracy from Utah wants to chime in a little bit about how to check them out in Utah, please feel welcome to do that, but I think everything might be covered here. The CIWater toolboxes are available for free through the Natural History Museum of Utah, and they can be reserved for 2 weeks at a time by filling out the request form on their website, which is listed here on this slide. There is also a CIWater toolbox available for checkout from Weber State University. And then you'll see under the third point there some further instructions on how to check out a box within Utah. You'd go to the Natural History Museum of Utah's website and submit the request found there. And then you will soon receive a confirmation email from the museum. And then once that is confirmed and you will confirm a date and a time for your toolbox pickup, you would be responsible for picking up the box from the museum and then eventually within or around 2 weeks returning it back to the museum. And those boxes are available for pickup and drop off Saturday through Tuesdays. And then in Wyoming, just in case there are some Wyoming teachers watching and listening as well, we have 3 CIWater toolboxes in Wyoming, one here at the University of Wyoming, one at the Science Zone in Casper, and one at the Teton Science School near Jackson. And depending on demand, these toolboxes can be borrowed for variable amounts of time. They may be able to be kept for a little longer than 2 weeks. And right now they can be reserved by contacting me, and my email and phone number is listed there. And then just a few last details on how to check out the box. It is recommended that you reserve the toolboxes at least 3 weeks in advance, so give a little bit of notice before you're ready to use the boxes. And like I said, the teachers must pick up and drop off the boxes. And I mentioned that there are 3 boxes. They're fairly large, so it would be difficult, maybe even impossible, to fit these boxes in a compact car. I know they fit in my Subaru Outback, but I'm not sure how well they would fit in many sedans or smaller compact cars. And if you have any questions, you're welcome to give either Tracy Collins at the Natural History Museum or me here at the university a call, and we can talk about the boxes a little bit further. And that is all I have on the CIWater toolboxes. So I will turn it back over to Tim.
Okay, well, thanks, Beth. That was those boxes look great. It almost makes me want to be a science teacher to be able to use those. Hey, I did have a question. Is that hydrology Monopoly game available anywhere else, or is it only part of the box?
You know, right now it is only part of the box. We certainly have copies of it in PDF, and I actually just sent the PDFs over to our copy center here because I'm going to use those for a Women in Science workshop for high school students here on campus next week. So it would be possible to get them that way and then, you know, print them out and be able to use them within the box. And when I sent them over to the copy center, I had them laminated just so that they can withstand use and laminating and cutting apart the cards. But they aren't really available anywhere else except our electronic files and the toolboxes themselves.
You know, this is for Lisa probably, but that would be or Jessica, that'd be a great thing to have on the website as a resource for teachers. Makes me want to play that game with my own kids. Anyway, great stuff. Some really good resources. So we appreciate Lisa and Beth and Tracy taking the time to present this to us today. And we're going to go ahead and wrap up our faculty lounge today. Also, in addition to wrapping up for today, we're wrapping up the faculty lounge for this year. Just want to thank everyone for a great year in the faculty lounge, and especially all those folks who have presented. I see a number of them here in the faculty lounge today, so we really appreciate that, and we're going to be off for the summer, so hopefully you'll have a good end of your school year and a great summer, and we hope to see you back next year in the faculty lounge. So thanks again, everyone, and we'll see you next year.